Hello, gentlemen. This video is going to expand upon what we did with the Laura signs in the last video. But we're going to look at something called the ambiguous case, where we can actually have more than one solution to a given triangle. And sometimes we'll learn that you can have no solution as well. Let's look at an example first to show what I'm talking about. Here's a given example. We have given that angle A is 60 degrees, the length of A is 9, and the length of C is 10. We're going to have what they call an ambiguous case, or we can have an ambiguous case when we have one angle and two sides. Okay, if we had two angles, we don't have to worry about it, but if we have one angle and two sides, we can end up with an ambiguous situation. So let's see what I'm talking about. I have the Laura signs right here. A over sine of A equals C over sine of C. And if I just simplify this out, and let's say that we're looking for sine of C here, we can do that. And if I continue here, if I plug in, I get 0.962. Okay, and then obviously to solve for that, I'm going to look at having sine of C is equal to 74.15 degrees. And so basically what I'm doing is I'm saying that angle C is equal to arc sine of 0.962. Okay, and we know that sine is always positive between 0 and 180 degrees. And I also know that there's two times when C, two angles between 0 and 180, that are going to satisfy this equation. If we remember what the sine function looks like, sine starts at 0 and goes like this. Oops, sorry. Comes here. And that's 0, that's 180 degrees, with a maximum of 1. So if I look at this right here, and I go across here, see that's 0.962, I'm going to hit two different angles that are going to satisfy this equation right here. Arc sine's only going to give me one of them. Arc sine will give me this one right here. Remember, arc sine gives us a value from negative pi over 2 to pi over 2. I want to find that other one too. And to find that other angle, it's just 180 degrees minus whatever that original angle is that we found. So if the first angle is 74.15, B, because again, some of the angles in a triangle is 180. So to find B here, I said 180 minus the 60, which is angle A. This is angle A, minus 74.15. That's angle B right there. Okay, and that's how I got that. Now, what you should also note is that I can have another value for angle C. And that other value for angle C, I find it by going 180 minus the 74.15. Okay, and I get 105.85 here. What you should do now is plug this into your calculator. Do the sine of that angle and do the sine of this angle. They're going to be the same. Okay, so this is where we get into what we call the ambiguous case. Because now I can have another value of B. They all work because the sum of the three angles is going to add up to 60 degrees. Okay, so we have to make sure that we're checking when we just have one angle and two sides. That's a situation where we have to check for the ambiguous case. Okay, let's finish this problem up because we're going to have two different values for side B. All right, so I can use my law of sines. What it's going to allow me to do is solve for for the length of side B. But again, remember that I'm going to have two possible answers because I have two possible B angles. Okay, so if I look at the first one, if I look at this one right here with sine of 45.85, I'm going to get B is equal to 7.46. And then if I look at the other angle, I'm going to get B is equal to 2.54. Okay, so I'm going to get two different triangles. There's one of them right there where B was 45.85 and C was 74.15. And then we'll get one where we're 105.85 and 14.15. All right, so that's what we call having an ambiguous case. All right, here are some general rules to find out, how many solutions that we should expect. I'm gonna go through and look at a way where you don't necessarily have to memorize all of these different situations. But we can just look at and go through a problem, and when we go through it, the results of each step will tell us if we're going to have one solution, no solution, or two solutions. Okay? But you should look over this because it is helpful. Let's do another example. Given angle A, side A, and side C. Again, this is a situation where we've got to be aware of it because I have one angle and two sides. If I look at setting up the law of sines, I get A over sine of A equals C over sine of C. If I manipulate that to look at solve for sine of C, I get sine of C is equal to C over A times sine of A. Just doing some cross multiplying and dividing by A. If I plug in here, what I'm going to get is 1.5. Sine of C is equal to 1.5. And at that point, you try to solve and plug it into your calculator and you get no solution. And the answer is, the question is first is why, but the answer is you should understand that the range of the sine function is between -1 and 1. And there's no value, no angle that I can plug in for C that will produce sine of C is equal to 1.5. So this is a solution, this is a situation where we have no solution. The given information will not form a triangle. Okay? Let's look at another one. I'm given angle A again is 76, and I'm given side A and side B, and I want to solve for the other sides and the other angles. Again, I have to be aware that I could have an ambiguous case here. So let's go about solving the way we'd solve for sine of B first. If I do that, I solve for sine of B. I get B over A times sine of A, okay, which will give me a value, gives me 0.599. And so I can solve, I can use my calculator, and I can get angle B is equal to 36.8, okay? And then if I do that, I can find C again because the sum is 180, the sum of the angles in a triangle is 180. Now I also said you have to check for the ambiguous situation again because I have one angle and two sides. And to find that other angle B, I go other angle B can equal 180 minus 36.80. If I do that, I get 143.2. So if I plugged in sine of 36.80 or the sine of 143.2, they're both going to produce a value of 0.599. However, this one is not a solution. Okay, this one's not going to work, and the answer is pretty simple. If you look at it and understand that the sum of all the angles in a triangle equals 180, you're going to see why 143.2 doesn't work. Because if I simply add 143.2 to 76, I'm going to get 0.29, 11, 219. I don't even have another angle. I need to add another angle here. Obviously, I'm over 180 degrees. So this is a situation where I only have one solution. Okay? So basically what we would do is solve for an angle, get the acute angle, one less than 90, make sure we know that one's going to work. And then what we're going to do is 180 minus that angle and see if I can add up to less than 180. If I can add up to less than 180, I'm going to have two solutions. Otherwise, I'm only going to have one. And possibly if this value here, right there, turns out to be bigger than 1, I'm not going to have a solution at all. Okay? Well, let's finish solving this. Again, we're only going to have one solution, so I only have to work with these angles right there. So now what we can do is we can find the side C right here, again using the law of sines. Bring the sine of C over, right over here, bring it over to that side. Simply plug in, and we get C is equal to 32.3. Okay? So here's some more practice. These have some that have the ambiguous case. Make sure, again, you're looking at these examples. One example is a no solution example, one is a one solution example, and one is a two solution example. So make sure you're paying attention to those. These will help further your understanding about the law of sines and when we have more than one solution or no solution. Again, if you have any questions, make sure that you're emailing me. Okay, fellas? Have a good day.